Hello, I am Kritika Tank. In this video, we are going to learn about angle between two lines of regression and their application in the field of computer science. The agenda for today's presentation is Introduction to the lines of regression, formula for angle between two lines of regression, applications of lines of regression in computer science engineering, and then lastly, conclusion. Now let's understand curve of regression. So first we will plot a scatter diagram, that is a graph of dots plotted with the values of dependent and independent variable. In the diagram here on the right side we can see that if two variables are related, the points on the scatter diagram will be more or less concentrated around a curve called the curve of regression. In this diagram we can see the points are concentrated in a diagonal line. Lines of regression. If this curve of regression is a straight line, it is in case of linear regression, and the straight line is called the line of regression. These lines express the average relationship between the variables. In linear regression, we find the lines of regression by the concept of curve fitting using the principle of least squares. Regression lines are the lines of the best fit so that they try to cover as many points from the scatter diagram as possible. Why are there two lines of regression? The method of least squares minimizes the sum of squares of the error from a specified value. Depending upon which variable we select as the dependent variable from x and y, we can get two lines of regression. The first line is the line of regression of x on y. Here we use this line to find the value of dependent variable x for a given value of the independent variable y. We use the least square methods to minimize the squares of the errors of the available value of y from the mean of y, that is called y bar. Line of regression of y on x. We use this line to find the value of the dependent variable y for a given value of independent variable x. Here we use the mean of least squares to minimize the squares of errors of the available values of x from the mean of x, that is called x bar. Formula for line of regressions. The line of regression of x on y is given by the equation x minus x bar is equals to r sigma x by sigma y into y minus y bar. And the line of regression of y on x is given by the equation y minus y bar is equals to r sigma y upon sigma x into x minus x bar. Here x bar is the mean value of x, y bar is the mean value of y, sigma x is the standard deviation of the values of x and x bar, sigma y is the standard deviation of values of y and y bar. R is the correlation coefficient. According to these formulas, we can see both these lines pass through a point, that is x bar comma y bar. Thus, this is the point of interaction between the two lines of regression. Angle between two lines of regression. We have seen that the two lines of regression intersect at the point x bar comma y bar. Therefore, for a correlation that is not perfect, the two lines will be at an angle theta to each other. This angle between the two lines theta can be found by the formula. Theta is equals to tan inverse mod of 1 minus r square upon r into sigma x into sigma y divided by sigma x square plus sigma y square. Here, sigma x stands for the standard deviation of the values of x from x bar. X bar is the mean values of x. Sigma y stands for standard deviation of the values of y from y bar, where y bar is the mean values of y. R is the correlation coefficient. Now let's discuss application of angle between two regression lines in computer science engineering. The concept of the angle between two lines of regression is not commonly used in computer science engineering. However, regression analysis is widely used in various areas of computer science, such as machine learning, data analysis, and pattern recognition. In these fields, regression is primarily used to model relationships between variables and make predictions or estimations. While the angle between two lines of regression is not a common matrix, there may be scenario where it can be used in computer science engineering. Here are a few potential applications: feature selection, change set detection, and cluster analysis. These are just a few examples of how angle between two lines of regression could potentially be applied in computer science engineering. However, it is important to note that the suitability of this matrix will depend upon specific problem, data set, and the context in which it is being used. Now, let's look at the first application, that is feature selection. In machine learning, feature selection plays a crucial role in building effective predictive models. The goal is to identify the subset of features that are most relevant to the task at hand. The angle between two lines of regression can be used to compare the relationship between the different set of features and evaluate their sustainability. For example, suppose you have two sets of features, feature A and feature B, and you fit regression lines to the target variable using each separately. By calculating the angle between the lines, you can assess the similarity or dissimilarity of the relationship captured by the two feature sets. If the angle is close to zero, it suggests that the two sets are highly correlated, indicating redundancy. On the other hand, a larger angle indicates difference in the relationship and potential uniqueness of information provided by each feature of the set. By considering the angle between multiple set of features, you can prioritize the ones that offer diverse or independent information, thus improving the robustness and interpretability of your models. Now, let's look at the second application, that is change detection. The angle between two lines of regression can be used as a measure of change or trends in the time series analysis or monitoring systems. When dealing with temporary data, it is often important to identify shifts or anomalies in the patterns. To apply the angle between regression lines for change detection, you can segment the time series data into different intervals and fit regression lines to each segment. By comparing the angle between the lines, you can identify significant changes. A sudden or a large change in angle would indicate a shift in the underlying pattern of the data. This approach can be useful in various applications such as detecting system failures or anomalies in sensory data, identifying trends in financial market, or monitoring network traffic for abnormal behaviors. The last application is cluster analysis. In some scenarios, regression lines can be employed to summarize clusters or group within a dataset. Cluster analysis aims to identify distinct groups or patterns in the data. By fitting separate regression lines to different clusters, you can assess the dissimilarities between them. For instance, in a dataset with multiple clusters, you can fit regression lines to each cluster separately. The angle between these lines can provide insights into dissimilarities or separability of the clusters. If the angle is large, it suggests that the cluster have different relationship between the variables, indicating distinct patterns. Conversely, angle that is small indicates similarity or overlap between clusters. By considering the angle between regression lines for cluster analysis, you can gain a better understanding of relationships and difference between groups with your data, potentially leading to more accurate and meaningful cluster results. It's worth noting that the application mentioned above are not the conventional uses of regression analysis, but rather a creative way to leverage the angle between regression lines in specific contexts within the computer science engineering. The suitability of these approaches depend on specific problems, data set, and goals of analysis. Thank you.